how to measure torque and how to measure motor speed. We're given the M260 motor. M260 motors, they're little guys. Came in our Spark renter's kit. And you use them in circuit number 12. It's great to write it down and come up with ideas and everything. It's another thing entirely to actually do it. I've already done this video, but I used a lot of fancy equipment to use all this stuff. And not everyone has that stuff. You know, power supply, oscilloscope, and great multimeters and stuff like that. So I thought I would do it with basic equipment that everyone should have. Everyone doing this course would have. I'm going to use a mid-range multimeter. It's an X-Tech EX330. It has a frequency counter function. I'm just using the example sketch number 12 that we do in our SICK circuits. What are we going to do first? We're going to measure speed. How do we measure speed? I'm going to try it a few different ways. I'm going to show you how to do it by bouncing light off of it. So here, you can see what I've done here. Can you see it? You can kind of see that I've painted this thing. Gone half and half. So I painted half of it black. I also painted the shaft itself. So can't really see the shaft, but you'll have to trust me. Half of it's black. So what's going to happen is we're going to bounce light off of this thing. And it will bounce more off of this shiny shaft and the opaque whitish gear tines here than it will off of the black painted bits. And we can sense that changing light, and how often that thing changes is going to be the rotational speed. SparkFun gives us the number 6,600 RPM for this motor. It's supposed to be the maximum RPM. We're not going to be measuring in RPM, we're going to be measuring in revolutions per second. 6,600 RPM is 110 revolutions per second. You can divide by 60, or 110 hertz. First, we're going to use the most powerful light that I've got. 5 milliwatt green laser. There it is. This guy should be able to give us a very strong signal, make it easy for us to line everything up, calibrate it. Perhaps it's a bit big. It might be a bit big for your application, but let's start with this thing because it'll make everything easier. So that's the first light source. The second one I want to use is our ambient lighting. So I have some pretty good shop lights here. These IKEA lamps with incandescent bulbs going on. These guys, just regular ones. And then we'll try out some LEDs as well as a light source. This came in our SparkFun kit, so might as well just try some of those out. We have a bunch of colors, and the color probably does matter. So the other half of what we're doing here is figuring out sensors. SparkFun kit, they give us these light sensitive variable resistors. They vary their resistance based on how much light is hitting them. How much do they vary their resistance? Let's find out. Let's cover it up a bit. There I am, covering it partially with my finger. We're at 25-ish kilo ohm, and uncovered drops to 4 kilo ohm. What about with the laser? In the back of the laser, Well, depending on how I line it up, I'm not very good at it. It's in the hundreds of ohms. This thing pairs really well with the 10 kilo ohm resistors that we have in our pack. What I've done is I've taken this sensor and I've soldered one of these 10 kilo ohm resistors onto one of the legs, and then I took a bit of shrink tube and wrapped it around the sensor like that to keep all the light out, and it looks like this now. Okay, so that's one of the sensors. What else can we use? We can actually use LEDs with the sensors as well. So these guys, we usually use them to emit light. It just so happens that these things can detect light as well. They're not very good detectors, but they're probably good enough. One thing that they do very well is that they're very fast. These are diodes, so they can detect relatively high frequency signals. Let's try a green one, then we can test it out with the green laser. So I hooked it up. Let's try to just measure a DC voltage. This thing. So it's not measuring very much right now. I've got ambient lighting going on, measuring 240-ish millivolts, so 0.25 volts. What happens when the ambient lighting gets really close to it? So now it's 370 millivolts, 0.366367. So it is reacting to it. What happens when I turn out the lights? There's still a little bit of lighting going on behind me here. Look at that. Down to below 10 millivolts. Turn the lights back on. Actually, before that, let's try the big gun out. Alright. What kind of voltage can we get from that? Look at that. 1.6 volts. 1.3 volts. That's not bad. Let's set this up. So we're going to use this light-dependent variable resistor first, as our light sensor. Well, I've got the sensor hooked up now. Soldered on some longer wires just to make it easier to hook up. Let's see what we're reading. When it's covered up. 4-ish volts. And then when it's facing down, kind of in the shadow here, 2 volts. And in direct light, ambient light, 0.6 volts, 0.7. And the laser, less than 100 millivolts. 0.1 volts, 0.08-ish. There we go. Let's get it running. I'm going to type in the speed here. I'll restart it. There she goes. So you can hear it grinding a little bit, so I'm just going to fudge it off. Just like that. Now we're measuring a DC voltage here. That's not going to tell us what we want to know. This is kind of like the average voltage that this is reading. We want to see the AC voltage. We want to see what is the voltage change that this sensor is seeing, which is the AC. So there's a voltage change on here of about 1/4 of a volt, 0.254 volts. That's quite stable actually. That's quite large as well in terms of signals. Let's see if that signal is large enough for this meter to pick up the frequency. Great. Perfect. It's measuring between 141, it's not entirely stable, and 160. So let's say it's 150 hertz. So 150 times 60. Yikes. That is 9,000 RPM. What's going on here? Maybe we need to adjust. It should be more stable than that, because it's not going 9,000 RPM.